Thank you, and hello. Today, I'll be talking to you about the case for augmented reality on the web. I'm Marley Rafson. I'm a software engineer at Google. I'm on the WebXR team, and my Twitter handle is mprafson. I'd love to hear your thoughts about the talk and just continue the dialogue later. So the two things that we're talking about today are the web and augmented reality. So I believe that the combination of these two things is the whole is greater than the sum of its parts situation. So I think that there's things that the web will gain from augmented reality and things that the augmented reality will certainly gain from the web. So to begin, let's just start by getting everyone on the same page, and let's define augmented reality. So augmented reality is the mixing of computer-generated content with the real world. So to me, the implication of that is that we can now add contextualized information into the world around us. So for example, you're trying to make a coffee and you're at the coffee machine, and now you have the instructions overlaid on top of the coffee machine. And another implication of augmented reality is that you can now interact with 3D content in a 3D space. So if the canonical example would be you're trying to buy a piece of furniture and you're able to put it into your room before you buy it. So let's look at what augmented reality looks like today. Today, this is smartphone AR. So this is run using a smartphone, and it basically has some understanding of the world around it, which allows virtual content to interact with that world too. We also have augmented reality on headsets. So your hands would be free, and you'd be able to interact with the content using your hands. And a third example that I think is less talked about, but I find really compelling, is audio-based augmented reality. So what you're seeing there is Bose frames, and it's a pair of sunglasses that have speakers that kind of shoot audio into your ears. And with that example, so with audio AR, you would have that experience where you're at a coffee machine and you don't know what to do, but instead of seeing the information, it's read off to you. And I'd also like to say, if you hear me say AR, that's just short for augmented reality. So this talk, as I mentioned, it's also about the web. So let's talk about where those two things intersect. So that's what we'll call the immersive web. And the immersive web is the use of augmented reality, virtual reality, and other 3D technologies on the web. And so it's this whole spectrum of things. It can be more augmented reality than virtual reality, and it doesn't quite matter. And you'll also hear me say XR, and that really just stands for wild card reality. So it could be virtual, it could be augmented reality, and it could be some combination of the two. So today, what the immersive web looks like is something like this. We've seen progressive enhancements of sites that we use every day. So on the left two examples, you'll see Facebook 3D posts, and they're incorporated directly into the newsfeed. So that first example is a 3D model that you can interact with on the newsfeed. The second is using portrait mode depth information to allow you to delightfully play with these photos with a bit of depth added. And the third example is from Wikipedia, who about a year ago started supporting 3D models in their articles. So if you're not a large company and you don't have a whole engineering team dedicated to building this model viewing experience, there's a solution to that now. So recently, a team at Google open sourced a web component for viewing models. It's called Model Viewer. It's really fantastic. And so using just HTML, you can add a model into your site around it. So that's an example using the astronaut, which we all know and love. And something that's really great about the Model Viewer team is that they're thinking about accessibility early. So they've already incorporated alt text into the component. So let's say you have these 3D models on your website. How do you actually get it into augmented reality? So right now what we've seen is implementations of native system viewers that allow for augmented reality. So this is not running in a web browser, but there's this really slick and tight integration with the web. So you would have this search result, so it's integrated into search with Google. So you can tap the button, and then it intents into this native viewer, and then you can place it in augmented reality. And the same thing exists on iOS, and it similarly intents. And so what I just said there was that we're using native viewers to do augmented reality. But at some point in the future, we'd probably like to do that in the browser itself. So that's where the WebXR Device API would come in. The WebXR Device API exposes low-level sensor information, so the camera pose, if you can place an object on the floor, and that's under development. It's open, so we can all contribute to it, and you can find that on GitHub. And with those examples that I just shared, that's all talking about bringing immersive technologies into the web, but we can also bring the web into immersive technologies. So here are two examples of XR browsers. So on the left, you'll see from Magic Leap, the Helio browser, and they're placing web pages into the world around you. And on the other side, you'll see Firefox Reality, which is a VR browser. So I think the immersive web today is fantastic. I think it's adding information, it's making it more delightful to browse the web. But when we're developing these technologies, it's important to see where we're going next and to start thinking about that earlier rather than later. So when I think about a future of augmented reality, I start by thinking about how can this assist me? So I think about maybe I'm leaving work one day and I'm wearing these lightweight AR goggles, I'm walking down the street, I'm looking for dinner. So as I look at the restaurants on the street, I'm seeing Yelp data populating with the stars rating and the types of menu. And maybe I also want to see photos of the food, so Instagram information's coming too. And I like Pokemon, so maybe while I'm doing all of this, I'm also catching Pokemon, playing Pokemon Go. And when I get to the train station, I'll have information populated for me telling me which train to take so that I can get home fastest. And as I mentioned earlier, I probably don't want to be restricted to doing this on just one headset. Maybe I want headphones another day from a different company, or who knows. And maybe I just want to use my smartphone. So when I'm thinking of this vision of augmented reality going forward, I start to see some interesting things and patterns that I'd like to call out here. So the first is that it inherently uses web content. I want access to all the things that I already use when I'm browsing the web. Another thing is that it's this really interesting composition of different types of information. So that could be models, it could be 2D pages, and we're going to have to interact with them in a way that's aesthetic and delightful and still makes me want to use it. And one third trend that I start to see is that we're really interacting with the world around us. So I could be placing information onto a building or on a tree or on passing by cars. And so when I start to think about this vision that I want and where we are today, which is mostly placing 3D models, I think there's a lot of work to go. And where I see a lot of that work coming into play is with a user agent. So the definition from W3C of a user agent is any software that retrieves, renders, and facilitates end user interaction with web content. So today, that's usually just your browser. So you get a lot of things when you're browsing using any of the modern browsers. So that could be Chrome, it could be Firefox. It helps you do safe browsing. It renders the HTML pages for you and things like that. So to understand how a user agent will play out with this added dimension for augmented reality, let's start to break down this definition of a user agent. So I'll go in reverse order. So let's start with a user agent facilitates end user interaction with web content. So what I believe is that the user should always be in control of how information is presented to them. So on a modern web browser, that's preferences like default text sizing, that's contrast ratios, and Chrome extensions, and things like that. But when you think about augmented reality, we have this whole new dimension, and it's really immersive. It's, and so we need to start thinking about other ways that we want to have safe browsing, and we want the user to be in control. So one example would think about physical proximity. So you have content that's being rendered possibly close to you, and I should be able to say, I'm not comfortable with anything rendering closer than 5 meters away from me. Or I also think it's compelling to think about this in terms of sound. I probably would never want to allow someone to whisper into my ear as I'm walking down the street. So a lot of these considerations come into play when we're talking about augmented reality. And in order to accommodate these things for the user, we're going to need an intervention point for this information. So the user agent needs to know what's being asked of it to incorporate this. So if we think about some declarative content that we all know and love, that would be HTML and CSS. And so I see this future where there's declarative content that you're able to add into the world around you. So you could specify things like, I would like float left and pin to a building. Or you could say, I want the depth to be 5 meters from the user. But it's up to the user agent to decide whether or not it can actually honor that request. And it's in that way that it can advocate for the user. So another thing that declarative content offers is that it provides semantic understanding for the user agent. So what that means is that the user agent actually has a view into what's being asked to be rendered or presented to the user. So I find this example extremely highlighting of what I'm talking about with that thing. So if we look at the left side, we see WebGL inspectability. So if you're just given this canvas to render a 3D object, which is how it works on the web today, if you're given an XY location on there, you can only see the color. So you could say, I see a black pixel, I see a white pixel, a gray pixel, but nothing more than that. But with semantic understanding of what's actually in the scene, we have a much more rich understanding of the models and the content that we're placing. So if you look at the right side, you can see I'm looking at the windshield, and it has a material that's glass, and it's transparent. You can also see things like the tire and stuff like that. And so you can imagine with screen readers or accessible or just translating this into sound-based AR, you can actually talk about what the user's seeing. So you could say, I see a van with black tires and white car metal paint. So the next part of the user agent that I'll talk about is rendering. So the user agent is responsible for rendering to the browser. So modern web rendering engines are amazing. They're fantastic. That's Blink, Gecko, WebKit, things like that. When you think about what they're asked to do, it's mostly 2D and it's text-based. So they're fantastic at rendering pages like The Verge at 60 frames per second. And some of you might know, and some of you might not, but the web already does do performant 3D rendering. It's really great, and that's provided to you as the user through a canvas element, and then it uses WebGL to actually create those graphics. And so what that might look like on the web today is this. This is not augmented reality or virtual reality, but it's just rendering in a web page using a canvas and WebGL. So for the rendering needs of augmented reality, which if you think back to that vision is this complex composition and layout dynamics of content, so we're going to probably need to build a rendering engine that can handle that from the ground up, whereas the modern rendering engines were optimized for 2D. And so even though I just said that we probably want this optimized from the ground up and that we don't want to use canvas elements, we tried it. So my team experimented on this internal prototype that we call AR WebView. And AR WebView is a set of libraries that enable web-based AR in native apps through system web views. So a system web view is just a lightweight browser that you can embed into a native app. And so the technical understanding of what we've done is that we have web-rendered virtual content, so we're using a web page to do that, and we're compositing it with native tracking, so that's ARCore and ARKit, and we combine that with a natively rendered camera feed. So let's look at what that looks like. So if you look at this example, we have a stormtrooper, and it's convincingly rendered into the space around you. And so what you need to do is you have to make sure that the content that's rendered moves at the same time as a native camera feed, because if it's off, it completely breaks the illusion. So we have that transparent web view, it's rendering the content, and this actually becomes a very difficult technical problem, because if you're familiar, and don't worry if you're not, but so you have a render loop that's running from the browser, but then you also have a render loop that's running natively, and you also have the update loop for the native tracking. So it's figuring out a way to get all of these things working together in a performant way. And the advantages of AR WebView is that it's lightweight. It's only 60 kilobytes to add it to your app. It's cross-platform, so you write code once and it works on both iOS and Android. It's embeddable into native apps, and you can pull down content and code on demand. And that last part, to highlight the advantages of that, is that you can make changes to this augmented reality experience that's independent from your native app code. So you don't have to wait for an app release to change your AR experience. So one use of AR WebView in action was at Google I/O this year. So if you were there, you would have seen this experience that allowed you to orient yourself in the once you're on site at the conference. And so using augmented reality, you could look around and see which way you might want to go next. And so this experience is literally just a web page. And those white texts that say Water Station Eats Market are actually just HTML elements styled with 3D transforms. So again, AR WebView, it's a prototype, it's internal. We had a lot of fun and we learned a lot with it. So this last aspect of the user agent that I'll talk about is that the user agent retrieves content on behalf of the user. And this part is so fascinating to me. So if you think back to this vision of augmented reality, you're walking down the street and you look at a restaurant and it knows what you want is the menu information. And it knows what you want is the Instagram photos. And so if I was doing this today on my smartphone, I would go to the restaurant, I would see the name, I would type it into maybe Google search, DuckDuckGo, who knows, and then I would access the information that I wanted. But what we have with augmented reality is this fundamental paradigm shift. So now the user agent is querying on my behalf, and it should know what I want to see. And that's very interesting. So in a camera-first browsing environment, the user receives content rather than querying for it. And the implication of that is that the user agent gains discretion over content surfacing. And this is a very interesting question right off the bat. So we can think about modern questions that we're having about echo chambers and things like that. So imagine you're in an augmented reality immersive world, and you don't know when there's content that you're not seeing. Or you should just have a way to know, and you should have ways to set preferences on what you do want to see. And I think that there is kind of this pessimistic view of that, but I also think that there's a lot of advantages of having this intermediary between you and the information. So an example that I like to think of is, imagine you're a coffee drinker, and you wake up, you want to wear your AR glasses on your way to work, but you haven't had your glass of coffee, so you just want the bare minimum. And until you get to that coffee shop, then you're ready to get all the other things coming. So in that way, the user agent having discretion is an advantage. And so, as you start to hear these things about augmented reality, and maybe this future where everybody's wearing headsets, you might be like me yesterday in Conrad Electronics thinking, that's a lot of cameras. So, it's true. A camera-first future requires a lot of cameras. And it's not just augmented reality that's facing these things. It would be things like self-driving cars, where they have 6 sensors, 8 sensors, a ton of sensors, just sensing the world around it as it's continuing to process. And so if you think about what that actually means, is that we're now capturing basically everything that happens on the sidewalk, anything that someone wearing one of these headsets can see. And so as we try to build towards this augmented reality future, we need to have privacy and surveillance top of mind when thinking about world-scale AR. So at face value, I think one of the first things you'd think about in the context of privacy is that these cameras are capturing RGB data about the world around you, which is just a picture. So what happens with that picture data? Is your device computing it on device? Is it going up to a cloud? Who owns that data on the cloud? Is it going to your private cloud? And then when you think about secondary data, so that's information that's extracted from this camera image, which is how augmented reality works. You can imagine that if you're building up meshes around you, let's say you're someone that lives in an apartment building with a very distinct statue outside. So you walk out, you're headset creates some mesh of this statue, then someone could know that exactly where that statue is and then locate you. So even if they don't have the camera data, they can understand that from the derivative information that's used for augmented reality. And what I think, though, is that user agents being more powerful is actually an advantage in this scenario. Because if we can move that information away from the developer and closer to a trusted user agent, that's a positive thing. But we'll need something like open source code to actually know that that we can trust our user agents. So to me, augmented reality and the web is an amazing partnership. The web will gain a whole new access for understanding information. It'll be more contextualized. It'll be ergonomic. And for augmented reality, the web for sure is an important piece. It provides the content, and I love the webby principles that we use to develop today. And so I think that as we look forward to a future with augmented reality, we need to keep those webby principles in mind. And if you're interested in using and leveraging the immersive web today, you should go back and check out some of those resources I mentioned. So you should look at the model viewer and see if adding 3D models increases use and context to your information. And also start talking to us about the WebXR Device API. Everyone's opinion matters, and it'll be great for the ecosystem overall. So to me, if the web plus augmented reality is an open ecosystem of rich, contextualized information, then I'm excited, and I hope that you all are too.